Welcome to Cambridge Chemistry channel with Sarwat Ahmed. In this video I will be solving the questions which were found to be most challenging from 2019 paper 1 9701. So let's start. Question number 9. Ethane Dioxide can be oxidized by KMnO4 in dilute sulfuric acid. The products of this reactions are carbon dioxide, water, potassium sulfate and manganese sulfate. In this reaction, each ethane dioxide molecule loses 2 electrons as it is oxidized. A half equation for this process is shown. This is you know that the electrons are lost by the ethane dioxide, so it means this reaction is oxidation. This reaction is oxidation. So let's find out the reduction reaction. The reduction reaction can be ethane dioxide can be oxidized by KMnO4, and we have to find out the number of water molecules are produced when 5 ethane dioxide molecules are oxidized by KMnO4. So this is the, if we know that the oxidizing reagent is KMnO4, MnO4 minus plus 8 plus, this is oxidized. How do we know that this is oxidized, reduced? Mn2 plus, so this is reduction reaction. Electrons are gained. MnO4, in MnO4 the oxidation state of Mn is plus 7, as we know how we solve the oxidation state. MnO4 minus is equal to minus 1, Mn plus 4 minus 2 is equal to minus 1, Mn plus 8 is equal to minus 1, and Mn is equal to minus 1 plus 8 is equal to 7 plus 7. So oxidation state of manganese is 7 over here and plus 2 over here. The difference of electron is plus 5. So it means plus 5 electrons gained by manganate to form manganese ion. Now let's balance this equation. Add water molecules on the product side. Water molecules depends on the number of oxygen atoms. So over here oxygen atoms are 4, so we place 4 water molecule on the product side to balance the oxygen. So you know this reaction is going on in acidic medium, as we have seen in the question statement by KMnO4 in dilute sulfuric acid. So to balance hydrogen on this side, we add 4 to the 8 hydrogen ion. So this is 5 electrons, and over here in this reaction, oxidation reaction, there are 2 electrons. So multiply 5 over here and multiply this equation with 2. We have 2 MnO4 plus 10 electron plus 8 plus 16 hydrogen ion, 16 hydrogen ion to form 2 manganese ion plus 8 water molecule. So now this equation is multiplied by 5 HO2 CCO2H plus to form 10 carbon dioxide plus 10 hydrogen ion plus 10 electron. So 10 electrons are cancelled out. Now we have 16 H positive ion and over here 10 H positive ion and 2MnO4 2Mn 8H2O. So we have equation, overall equation is 2MnO4 like this, 2MnO4 plus 16H6H positive ion H positive ion plus 5CHO2 CCO2H to form 2Mn 2 plus 8H2O plus 10 CO2. So this is the overall balanced reaction, and we found that there are 8 water molecules are formed. So answer will be B. So this is how to calculate this equation, this reaction. So another challenging question from this paper is question number 11. The reaction between sulfur dioxide and oxygen is reversible in an equilibrium mixture at 1000 Kelvin. The sulfur dioxide concentration is 6 mole per dm cube. The sulfur dioxide concentration is twice the oxygen concentration. What is the sulfur dioxide concentration? We know that Kc is equal to and we know that over here in this statement the sulfur dioxide concentration is twice. Say if of oxygen is twice the concentration of oxygen. So let's assume that concentration of oxygen is X and concentration of sulfur dioxide is 2X. So this is equal to Kc's of this reaction is 280 is equal to 6 moles raised per 2 over here divided by 2x square and x. So this is equal to 280 is equal to 36 divided by 4x cube. And x cube is equal to 36 divided by 4 into 280, which is equal to 36 divided by 1120. Now by taking cube root on both sides 0.0321. So x is equal to 0.3178, that is oxygen, and 2x is equal to 0.636, that is sulfur dioxide. So what is the sulfur dioxide concentration? The option is D. Next question is 17, which was found to be most challenging by the students. The reaction of bromine with warm sodium hydroxide produces products with the same oxidation numbers in the same ratios as the reaction of chlorine with hot sodium hydroxide. In one reaction between bromine and warm sodium hydroxide, 30.2 gram of product containing sodium bromine and oxygen is produced. Which mass of sodium hydroxide has reacted? So this is the reaction of chlorine with hot sodium hydroxide. This is the chemical reaction: Cl2 NaOH to form NaCl plus NaClO3 plus 3H2O. So similar reaction with the bromine with hot sodium hydroxide plus sodium hydroxide, NaBr plus NaBrO3 plus 3 water molecule over here. After balancing we have 5, 6 NaBr. NaBr. So this is 30.2 gram sodium bromate. So let's find out moles of sodium. NaBrO3 Mr is 23 plus 79.9 plus 48, which is equal to 150.9. Mole of NaBrO3 is equal to 30.2 divided by 150.9. So mole is equal to 0.2. by using mole ratio. Sodium hydroxide plus ratio NaBrO3 6:1. X is equal to ratio 0.2. The mole of sodium hydroxide is X is equal to 6 into 0.2, that is 1.2 moles of sodium hydroxide. So mass of sodium hydroxide is NaOH is equal to mole 1.2 into mR of sodium hydroxide is 40, which is equal to 48 gram. So answer is D. Next question is 20. The diagram show two different compounds, compound 1 and compound 2. What is the total number of structural isomers including compound 2 that could be formed by adding second methyl group to the ring of compound 1? The number of pi electrons in each compound. So you know that this is the compound 1. We know that hydrogen is, and this is carbon surrounded by 2 hydrogen atoms. This carbon is surrounded by 2 hydrogen atoms, and this carbon is surrounded by H, and this is methyl group, and this carbon is surrounded by H. So methyl group, as question says, including compound 2 that could be found by adding second methyl group. So CH3 replaced by hydrogen atom. Like if we replace, this is with CH3, now this is with CH3, this is with CH3, and this is with CH3. We have 1, 2, 3, 1, 2, 3, 4 and 5 carbon. So CH3 is replaced with 5 hydrogen carbon atom. So in this way we have 5 structural isomers can be obtained. 5. And how many? The number of pi electrons in each compounds. As we know that there are 2 double bonds present in this ring structure, and we know that one double bond in one bond is sigma, and this is pi bond, second is pi. Over here similar, one is sigma and other is pi. So it means if 2 pi bonds are there, so the total 4 pi electrons are there in this structure. So the option is C, 5 number of isomer, D, the 5 number of isomers and 4 pi electrons. Next question is 26. Structural isomerism and stereoisomerism should be considered when answering this question. 3-methyl-hexane 3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula C7H14. 3-methyl-hexane 3-ol, how many isomeric compounds could be formed in this reaction? This is to form several isomeric compounds with molecular concentrated sulfuric acid. So concentrated sulfuric acid, this H is removed from this carbon and this OH removed. So by removing this H from this carbon and this OH from this carbon to form, and this H also can be removed, this H also can be removed. So when it reacts with hot concentrated sulfuric acid, so we have the structure C double bond, carbon H and H, carbon and carbon. This is another possible structure, C, carbon, double bond, now double bond in this position, H, carbon Another possibility is C. Now double bond is placed over here. So in this structure, three structures are formed. In this structure, this is structural isomers 1, and in this structure there are two possibilities, cis and trans. So like this is cis carbon and H3C. So this compound has two isomers, cis and trans. Now this compound also has two isomers, cis and trans, like this. CH3, CH2, CH2 and CH3, and similarly H3C, H, and this is CH2 and CH3, CH3. So this is one compound, CH2. So two different, each double bonded carbon has two different groups, CH2, CH3 and CH3. This is another different group, and this double bonded carbon HCH2 and CH3. So two possible structures with this compound, two possible structure with this compound, two possible structure from this compound by having cis-trans isomer and cis-trans isomer. Because when sulfuric acid react with this compound, there are three possible structures are formed. This is only one structure, that is structural isomerism, and this is over here. For this structure there are two possible structures, cis-trans isomers, geometrical isomers, cis-trans isomers, geometrical isomers. Because in cis-trans isomers there should be a double bond. The condition is there should be double bond, and each double bonded carbon must have two different groups. In this compound, this is two conditions are fulfilled, and in this compound two conditions are also fulfilled, that there must be carbon to carbon double bond, and each double bonded carbon must have two different groups. So there are total 5 isomers are formed. The option is C. Next question from this paper is 28, which was commonly wrong. Question is compound X is treated with two reagents successively, forming compound Z. This is aldehyde compound. X is aldehyde. Over here double bond, and this is ketone. A mild oxidizing agent react with aldehyde but does not react with alkenes in ring, and will not oxidize ketone. So the product Y will be like this. CO CH3, and over here C carboxylic acid. So when NaBH4 react with this compound, what will be the possible product? NaBH4 will not reduce carboxylic acid, so this is, and will not reduce, will not break L double bond. So COH same, but reduces ketone and form secondary alcohol. Ketone is reduced to form secondary alcohol. So this is the possible structure. If we write like this, CO2H and CHOH CH3. The option is A. Next question is 40. Carboxylic acid react with alcohols to produce esters. Carboxylic acid X forms one ester only with molecular formula C5H10O2. So next question is 40. Carboxylic acid reacts with alcohols to produce esters. Carboxylic acid X forms one ester only with molecular formula C5H10O2. What could X be? This is CH3 COOH. When react with propanol, to form propyl ethanoate with formula C5H10O2. CH3 C double bond O CH2 CH3, and formula is C5H10O2. This compound is formed by reacting another type of alcohol like this. So this is primary alcohol. Secondary alcohol can also react with CH3 CHOH CH3. So the compound is formed like this. So the formula is same, C5H10O2, but this propyl ethanoate is formed C5H10O2 compound in two different ways. Now let's check. So this is incorrect statement. Propanoic acid CH3 CH3 CH2 COOH plus ethanoic acid CH3 CH2OH. So there is only one possible structure of ethanol. So this is the only this product is formed like this, CH3 CH2 COO CH2 CH3 with formula C5H10O2. But there is only possible primary alcohol is with ethanol, so there is no other way to form C5H10O2. So this is correct. Butanoic acid CH3 CH2 CH2 COOH. And when this butanoic react with methanol, CH3OH, and CH3OH has the only one structure, and it is formed C5H10O2 formed like this: CH3, CH2, CH2COO, CH3 with formula C5H10O2. So butanoic acid is also correct. So the propanoic acid and butanoic acid only one way to form C5H10O2. The option is, if 2 and 3 statement are correct, the option is C. So these are the challenging question from 970 2019 paper 1-1. So if you like this video, please subscribe and share this.